Welcome to a new video. Today we are going to talk about support vector machines. I will first create the regression and classification models with base parameters, then I will show you how we can optimize models performance with hyperparameter tuning. So in this video you are going to learn support vector machines regressor, classifier, and then you are going to learn the parameters for optimizing the model performances. Let's start by importing the libraries that we are going to use. I'm going to import NumPy. I'm going to import Matplotlib. I'm going to import datasets from sklearn. I'm going to import train test split from sklearn.model selection. And then I will import sklearn.svm support vector machines. I will import support vector classifier and support vector regressor. So I imported NumPy for numerical operations, Matplotlib for plotting, and essential functions and classes from scikit-learn. We will first start with classification. So I'm going to use make classification for the data creation. So I will say x class and y class. Then I will say datasets dot make classification. I'm going to set the number of samples as 1000, and I will say number of features is going to be 2, number of informative is going to be 2, and number of redundant is going to be 0. So this is going to create a binary classification problem. Also, I'm going to plot this for making this information visual. Like I will say plt.scatter. I'm going to create a scatter plot. I will say x class, and we are going to take this. After that I will say x class, and we will say this. After that I'm going to set the c as y class. So I'm going to make plt.show. After that also I need to say plt, not pyplot. In this way it's going to work smoothly on here. So before running this plot, let's firstly check how x class looks like and how y class looks like. Great, so our target variable is 0 and 1, so it's a binary problem. I will say scatter. Also we can say plt.scatter, plt.title, classification, data. And also what we can do in here is we can change this number of samples data for making it clearer as a classification data set. Like I'm going to run this again, and since we changed this, it's going to be changed our data set because we are not setting a random state in here. If you just set a random state like random state 4D, you will get the same data every time, but I don't want that. I'm not going to use that. I'm just going to take a nice looking one. I want classes to be differentiate with I, so I think okay, this one works smoothly. Left side is for the purples, right side for the yellows. Great. Okay, now let's split this data into training and testing sets. So I will say xtrain, and I'm going to add classification like this class. I will say xtest, and I will say class. I will say ytrain, I will add class, ytest class, and I will use train test splits. I will say x class, y class, and I'm going to set the test size as 0.2, which means that 20% of the data we are going to be using is going to be in the test set, and the 80% of it is going to be in the training set. So I'm going to run this cell, and after that we are going to use the base support vector classifier class from scikit-learn, and we are going to initialize this like support vector machines classifier, and I will say this. I'm going to initialize this like that. And after that I'm going to train this classifier with our training data. Again, we are going to train our model with training data and test its performance with the test data. So xtrain class, ytrain class, and after training our model we can evaluate its performance. So we will say support vector machines classifier score, and we will give xtest class and ytest class. What this .score does is it gets the accuracy score. Also you can just import from sklearn.matrix import accuracy score but this one is quicker, so I'm going to use that for the accuracy calculation. 0.91. Great. So, okay. Here we see the accuracy score, which tells us how well our classifier is doing. Now let's shift our focus to regression. For that, we will use make regression to create a dataset. So I'm going to say x regression, y regression is going to be datasets.make regression this time, and I will say number of samples, let's say 500 for it to be equal with the other. Let's give one feature this time, and we will add noise like 0.1. It will be great, I guess. So let's also plot this. So we will say we are going to create a scatter plot again, plt.scatter, and after that I'm going to say x regression and y regression. Also let's rerun this, and after that I will say plt.title, and I will call this like regression dataset, and I will use plt.show after that. And great, we have a linear data, and we can create a linear regression with this kind of equation on this type of data. But today we are going to talk about the support vector regression. So it's going to perform well, I guess, because it's a linear model too. Our data seems great, so what we can do is right now, let's split this data into training and testing sets. So I will say xtrain regression, xtest regression, actually like this, and then I will say ytrain regression, ytest regression, and it's going to be train test split, x regression, y regression, and we are going to set the test size as 0.2. Okay, now we are going to initialize the support vector regressor class from scikit-learn. So I will say support vector machines regressor, and I will use this support vector regressor class after that. And what I'm going to do after that is I'm going to train my model. I'm going to use the training data I have. I will say .fit, and I'm going to say xtrain regression and ytrain regression. After that we are going to have a trained model, and let's get the R-squared score. So we will say support vector machines regressor .score, and we will say xtest regressor and ytest regressor. So this is an amazing R-squared score. Since our data is basic like that, I think it's because of that, and it's a really good R-squared score. By default, if you use score, it will give you R-squared in regressor, and it will give you accuracy score on the classification. Okay, let's talk about model optimization. Understanding how to properly tune the hyperparameters can improve the performance of your support vector machines models. So let's get started. We will use the grid search cross-validation from scikit-learn to perform hyperparameter tuning. So we will say from sklearn.model selection import grid search cross-validation, and grid search cross-validation allows us to specify a range of possible values for each hyperparameter we want to tune, and then it runs cross-validation for every combination of these hyperparameters to find the best settings. Now let's define the parameters we want to tune for our classification model, and then I'm going to talk about what these parameters are. So I'm going to say parameter grid, and I will say classification. I'm going to define C firstly. It can take values like 0.1, 1, 10, 100. You can extend these values by your decision. I will say kernel. We can give like linear, RBF, and polynomial. And after that I'm going to say gamma, and I will say scale and auto. And now let's talk what are they. C is the regularization parameter. Lower values result in wider margins but allow some misclassification. Higher values aim for a smaller margin and could result in overfitting. Kernel specifies the type of hyperplane used to separate the data. We have linear, RBF, and poly. So RBF stands for radial basis function and poly stands for polynomial. And gamma is the kernel coefficient for RBF and poly. So we are going to initialize this like grid search, and we will say classification after that, grid search cross-validation, support vector classifier, and parameters grid classification, and after that we will say, let's say cross-validation as 3. So we initialize that, and now we can train our model like grid search classification, fit, xtrain class, and ytrain class. So here I have instantiated the grid search cross-validation with our support vector classifier model, the parameter grid, and set cross-validation to 3 folds. It's now running through all combinations of hyperparameters to find the best one in the cell. So after that, what we are going to have is we can check for the best performing parameters, like we will say grid search class dot best and parameters, and we are going to get 10 for the C, auto for the gamma, and RBF for the kernel. By the way, this best is about your dataset and about the situation. You can extend these values, like you can add 1000 or 0.05, not in case because it's the middle, the best performing one, but you can just extend these numbers, like you can add 12, 8, and maybe they perform better. And if you extend these values, you are going to try more parameter options for tuning your model, so it will be better if you have training time. Great. So now we are going to tune our parameters for a regression model. The parameters are going to be the same, but I'm going to write them again for you to remember. And I will say parameter grid regressor, and it's going to be C. Let's give different values this time, like 0.005 and 1, 5, and 20. And we have kernel again. I will say linear RBF poly, and we are going to have gamma, and it's going to be scale and auto. Actually, there is a typo, scale, and great. So we already talked about them. So this time we will say grid search regression regressor, and we will say grid search cross-validation support vector regressor. After that, I'm going to say parameter grid regressor, and let's set the cross-validation as 3 again. And after that, we are going to train this model like grid search regressor dot fit. We will use x train regressor and y train regressor for fitting our model. Great. So let's call the best parameters from here. Dot best parameters like this, and 5 for C, scale for gamma, and linear for kernel. Just like before, the output will give us the best hyperparameters according to our regression dataset. But you can extend these parameters, like you can add 0.2 or something like that for finding exactly the best one. And that was all for this video. Thanks for watching. We talked about support vector regressor, support vector classifier, their parameters, and how we can tune them. Thanks for watching again. I'm creating content about data science and programming. You can subscribe to my channel for more. I have a full playlist of machine learning videos and projects on the channel. You can just check the channel's playlist site and you can see the projects, and I'm providing the data set for every project I do. So you can just do the projects and add to your portfolio. Thanks for watching again, and have a great day.